Alright, so this is our question number 3 on a past paper practice questions on the equations of motions, AS physics. These are your SUVAT equations that we are practicing here. Okay, so here is your question. It's a long question, so which is split across 2 screens. If you want, you can take a snapshot of the question, attempt the question yourself, come back and play the video again. So this is the first screen. Take the snapshot please, and just 2 screens are there. It's not a long question. Second screen. This is the second screen. Okay, so I believe you'll pause the screen and attempt the question yourself before you listen to my explanation of it. And in the meanwhile, please do not forget to subscribe to the channel if you feel that this channel is helping you to prepare well for your final AS exams. Right, so let us understand what is happening here. A ball is thrown from a point P, which is at the ground level as illustrated in this picture here, in this figure here. Okay, so the initial velocity of the ball is given to you 14.4 meters per second at an angle of 36 degrees to the horizontal. So let us write down this information. Initial velocity is how much? 12.4 meters per second. It is at an angle of 36 degrees to the horizontal. The ball just passed over a wall of height h. The ball is passing over this wall. The ball reaches the wall at 0.17 seconds. Now the time to reach the ball, or the time to reach the ball, is also given to you, which is 0.17 seconds. These 2 pieces of information is given, assuming that the air resistance will be negligible. Now this is also one piece of information which tells you that there is no other force acting on the ball apart from gravity. Not even air resistance is acting. So if the only force acting on the ball is gravity, the acceleration is, the statement tells you that the acceleration is g, because the only force acting is gravity, right? So let us understand what the first part of the question is telling. Calculate the horizontal distance of the point P from the wall. So you have to calculate this horizontal distance. Whenever you have to calculate the horizontal distance, what is the thing that you need to find out? You need to find out the horizontal component of the velocity, which is very easy to do here. Why? Because you know the initial velocity and it is at an angle of 36 degrees. So it is easy to find the horizontal component. It will be 12.4 cos of 36 degrees. Calculate it in your calculators. You'll get a number here. And then what you have to do, you have to find the horizontal distance. Horizontal distance, let us call it SH. Horizontal displacement, which will be VH times T. The T value we know is 0.17 seconds. So what is the value of VH? Calculate in your calculators and see if it is tallying with the mark scheme. It should be 10. Okay, so the answer here should be 10. So 1.7 meters. Let us tally with the mark scheme. Here it is. If you have worked out this question in any other way, which I don't think is possible, that's the only way possible to work this question out here, you should be getting the correct answer, which is 1.7 meters. Alright. Now let us come to the second part of the question. It is the same figure which I have taken again from the first screen. So we need not read everything again. It's the same picture I have taken here so that you understand the question. It is easy for us to solve the questions because the figure will be handy next to the question. Calculate the height of the ball. They are telling us to calculate the height. Now height is what? Height is a vertical thing. Now let us think everything in terms of vertical phenomena. So if we are talking about a vertical height, we need to be thinking about the vertical velocities, right? We need to be thinking about velocities in terms of their vertical component. So here the velocity was given to you in the question 12.4. So what is the vertical component of the velocity? What is the vertical component? Initial vertical component was how much? Will be how much? 12.4 sine of 36 degrees. This is the initial vertical component. You know the initial vertical component, you know the value of acceleration, which is same as g, which is 9.81 meters per second square. You know also the value of, what else have you calculated? You know the value of time. Is there anything else vertical thing that you know about? This is a horizontal velocity, you need not care about it. Horizontal displacement, you need not care about it. But the time taken to reach this position on the wall is also given to you as 0.17. Time is also given. Let us make a note. Always a good idea to make a list of the things which are given to you in the question. Which formula do you think makes sense to find the height, which is same as the displacement? Shall we look at the list of the equations of motion? The first formula doesn't make sense because we have to find S, and the first formula does not have S anywhere, doesn't make sense. Second formula, do you know the final velocity? No, you do not, doesn't make sense. Now the third formula, you know T, you know U, you know A, makes sense. The last formula, you do not know the value of final velocity, doesn't make sense. So let us work with the third equation, which is S is equal to ut plus half at square. Let us substitute the values. Substituting the values is also critical. Initial vertical component of the velocity, when you solve this, what is your answer? Please write it down. Let me check in the mark scheme. It was 7.29. The answer for the initial vertical component should be 7.29. So 7.29 multiplied by, let me write it more tinier font because we do not have much space. So 7.29 times the time, 0.167 plus half. What is the value of g? We are taking the upward direction as positive. G we know acts downwards. So the g will come here as negative. So minus 9.81. G is a negative value here because we are working with the upward velocity as positive. So anything which is down should be taken as negative. Times t, which is 0.17, the whole square. Do not forget this negative sign. Solve it in your calculators. Let's see with the mark scheme. Yes, they have a negative sign here. Your answer should be 1.1. Pause the screen, solve it in your calculator and see if your answer is 1.1. If it is not, please type in the comment box and let me know your confusions, your queries, so that I can clarify it. We'll have a talk, we'll have a chit chat in the comment box to clarify all your questions. So this is done. Let us come to the B part. A second ball is thrown from point P with the same velocity as the ball in A. Second ball is thrown with the same velocity. For this ball, the air resistance is not negligible. So air resistance is not negligible for the second ball. This ball hits the wall and rebounds. Sketch the path of this ball between P and the point where it first hits the ground. So how will the ball move? Because there is a backward air resistance as well. Air resistance always acts in the backward direction of the motion. It resists the motion. So overall what happens? The ball will not reach the maximum height. It will hit somewhere on the wall. It will rebound. It will rebound using the law of reflection. Draw a normal. Draw a normal on the surface. It will reflect something like this. Sorry, let me use the red color. It will reflect and then it will fall down. So that should be your motion. The ball will hit the wall. It will reflect. With respect to the normal, the angle of incidence and the angle of reflection should be the same. The ball is coming all the way. Let me take a ball and show you. You can think of my pointer as the ball. Ball is moving. It hits, it rebounds, goes up and falls down. So this is your 2-mark question. I'll show you the mark scheme as well. Read the mark scheme and see if you understand the explanation. The mark scheme also explains the same thing which I've just spoken about. Alright, so this was all about your questions on equations of motion. If you want me to post more questions, let me know.